Hello everyone from Math 1340 Statistics. It's Professor Wenson here again with a video for you on a KnewtonAlta assignment. This is for section 2.6 titled Skewness and the Mean, Median, and Mode. So of course I'm hoping that you've already read section 2.6 in your OpenStax book, right, the openstax.org book. I'm also hoping that you've already watched videos and taken notes on your reading and your videos and organized those notes in a way that'll make it easier for you to read later when you go to review for things. All right, now let's get into I'm just going to start straight up in the KnewtonAlta assignment. So again, you have your title up here. You won't see the word preview. Right, the mastery bar object. Now this particular section only has one objective, right? Some sections are shorter than others. This one is one of those short ones. So determine if a data set is skewed. Right, now, as I've been saying with all these, every time I come across a new objective, I would recommend clicking on more instruction. You don't have to. Right? You can try if you feel comfortable that you know what's going on. If you did your reading and watched other videos and you feel comfortable with the material, you can keep going without doing more instruction. But I'm going to do it here. Right. You've seen that I usually click on more instruction when I see a new objective. Alright, so I'll read some of these definitions to you. Skewed data. Data is said to be skewed if there is a main concentration of large values with several other much smaller values, or vice versa, if there is a large concentration of small values with several other much larger values. So let's look at the three types of distributions below, using examples with histograms. Alright, so I've drawn these pictures for you in a past video, pictures like these. A distribution is symmetrical when basically the left half of the data set looks exactly like the right half, or close to. It doesn't have to be exactly like. Alright, so this distribution here is definitely symmetrical. You see it starts off low, goes up higher, higher, and then it does exactly the same thing. It does the opposite of that on the other side. A symmetrical distribution. A distribution is symmetrical if a vertical line can be drawn at some point in the histogram such that the shape to the left and the right of the vertical line are mirror images of each other. Again, very close. Very close. They don't have to be exactly the same, but if it's roughly the same on both sides of the middle. Now, in a perfectly symmetrical distribution, the mean and median are the same. Right? If a distribution is perfectly symmetrical, so the left half and the right half are exactly the same in your picture, in your histogram, the mean and the median will be equal. And then the modes, not worried so much about the modes. The mode, remember, is the most frequent data value. You can have a one mode or two modes. I'm not going to worry so much about the mode right here. So that was a symmetrical distribution. Now, a distribution that is skewed to the left is kind of like, imagine taking a symmetrical distribution and pulling the left side longer. Pulling the left side and making the left side a little longer, pulled out to the left. So here's a picture that would be considered a distribution that's skewed to the left. You see how there's this long left tail here, and then it's heavier on the right. There's a thick, it's thicker on the right and thin and longer on the left. That's skewed to the left. So see, the right-hand side is denser with data values compared to the left-hand side. A distribution of this type is called skewed to the left because it is pulled out or more spread out to the left. Right. Now, in a distribution that's skewed to the left, the mean will be less than the median. Because remember how outliers affect the mean more than the median? So if you have more values, more lesser values, more values out to the left like this, where it's stretched out to the left, then the mean will be stretched out further left as well, and the median won't be as affected as much. So in a skewed to the left or a left skewed distribution, the mean should be less than the median. Now sometimes they'll be less than the mode, both of those as well, but again, if there was a bar out to the left here that was higher than this doesn't always happen, but the mean being less than the median is more likely to happen than them both being less than the mode. Right. Now in a skewed to the right, it's just the opposite. Right? Skewed to the right is, imagine taking my symmetrical distribution and just stretching it to the right, making the right tail longer. So a skewed to the right distribution is thicker or denser on the left, but longer or more spread out on the right. So it's skewed to the right, spread out further to the right, has a longer right tail and a thicker left side. So again, the left-hand side is denser with data values compared to the right side. Right. A distribution of this type is called skewed to the right because it is pulled out or more spread out to the right. And just as I was telling you earlier with the mean, remember how the mean is affected by outliers or larger values or smaller values. If you spread out to the right further, you'll have larger and larger values, which will move the mean out further right as well. The median doesn't get affected as much, but the mean will. So in this case, right, in a skewed right distribution, the mean will be greater than the median. And they might both be greater than the mode, but again, the mode, that's not always happening. But you see in this one here, the mean is 7.7, median is 7.5. The mean will be greater than the median if it's skewed to the right. Okay? So yeah, the general note they mention here, right? If a distribution of data is skewed to the left, the mean is less than the median, which is often less than the mode. Notice the word often here. That doesn't mean it always happens, right? But the mean should be less than the median in a skewed left distribution. If the distribution of data is skewed to the right, so that means it's thicker on the left, thinner on the right, stretched out more on the right, the mode is often less than the median. Again, often, right? That doesn't mean it's always happening. But the median should be less than the mean. The mean should be greater than the median in a skewed right distribution. Okay? And if you're, instead of looking at histograms, right, you can tell what kind of skew a data set has looking at a box and whisker plot. So hopefully remember what these all meant. Right? We've seen box and whisker plots before. If a data set is skewed right, it means the bulk of the data over here is on the left, and you see how it's stretched out further on the right. From the third quartile to the maximum is a big stretch. This 25% of the data is stretched further to the right. So heavier on the left, thin on the right, stretched on the right, skewed right. And if it's skewed right, that means the mean should be greater than the median. Skewed left is just the opposite, right? See how it's stretched out here from the first quartile to the minimum value, stretched out to the left, big left tail, and then the bulk of the data is to the right. But it's stretched left, skewed left. And in a skewed left distribution, the mean will be less than the median. And then a perfectly symmetrical one is, if you cut it down the middle, it looks about the same on the left as it does on the right. Right. And if it's perfectly symmetrical, the mean will be equal to the median. If it's close to symmetrical, and we'll see some things later that are close to symmetrical, the left side of the middle and the right side of the middle are about the same. If they're close to symmetrical, then the mean, should be approximately the same as the median. Right. All right. And again, definition of skewed data here again. All right, so let's get on here. That's the only objective, the only instruction. All right, now, based on that reading. And again, if you're in more instruction and you click on continue, get a question, you have all the instruction above you still. You can go back and look at it. Which of the following histograms shows a skewed data set? So you see how this one here is bulkier on the right and thinner on the left, looks more stretched on the left. This is skewed left. That's a skewed left set. This one is bulky on the left and thinner on the right. This would be a skewed right set. Now this one is bulkier in the middle and kind of thin over here, kind of thin over here. This is close to symmetrical. Again, you're not going to see perfectly symmetrical stuff very often, but this is very close to being symmetrical, right? If I cut it down the middle here at this tall bar, the right, goes down, the left goes down at about the same pace, and this isn't very stretched out. This is it's bulkier in the center, whereas this one was bulkier on the left, this one was bulkier on the right. So I'm not going to click on this one. This one seems more symmetrical to me, and this one's definitely more symmetrical. I think it's almost perfectly symmetrical. All right, cut it. It's bulkier in the center, thin on the right, thin on the left. Definitely has more symmetry to it. So I'd say just those first two. This is skewed left. This is skewed right. Looks good. Right. And again, the explanation. Right. Here we're given. This is which of the following frequency tables show a skewed data set. Now this time you're not given a picture. Right, but you could, you could use your calculator to make a histogram, or just kind of look at. Now, there are 4 of these. I'm not going to use my calculator for all 4 of them, but you could remember how to make a histogram on your calculator. You could do that with these tables, but really just think about it. Right, just look at it. Look at the frequencies. Right, remember the frequencies will be the heights of the bars in a histogram. Right. So I'll just draw these. I'm not going to waste time with my calculator, right, but I'll draw some of these out. All right, so this first one, right, if I'm making a histogram for this, and again I'm going to try my best to make this look decent. Got the values down here, frequencies on the left here, and the highest frequency I notice is 30, so I'll go like by 5s. There's 5, 10, 15, 20. And the values go from 0 to 8. So start that, say that 0 there, and then 1, 2, 3, 4, 5, 6, 7, 8. Right. So then I'm making bars. The value of 0 has a frequency of 2. All right. There's that bar, and then the value of 1 has a frequency of 11. Right, so just above 10 there. And the value of 2 has a frequency of 30. Or 32s, right? And then there are 22 3s. And there are 15 4s. Again, this isn't the best looking histogram. There are 12 5s. There are 6 6s. And there are 1 7 and 1 8. So 1 7, 1 8. There's a little tiny bars there. Okay, so it looks to me like the bulk of this is to the left, and then you see how it's kind of stretched out to the right. It's got this kind of shape, which has a longer right tail. Looks like it's skewed right to me. Now, you don't have to draw a histogram. You can see that here, how like it's very, the data values get very high. See how the data values get pretty high early, and then lower later, stretched out, and they're very low to the right. They're very high for the low values and very low for the high values. So this, I'd say this is skewed right, just looking at my histogram that I drew. Yeah, you can do that here. Now this one got like 4 lows, several highs, and it peaks and then it's pretty high in the middle here and then low. So this was high on the left. It was only low for one thing, but it was mostly high on the left and low on the right. This is low, then high, then low, which is pretty symmetrical, right? It would be like low, then high, then low, right? Like something like that. Very much more symmetrical than the previous one. So I'm not going to say this one. This one doesn't seem very skewed. It seems more symmetrical. This one, low early and high, low to the left. It'd be low to the left and then high to the right. This is skewed left. Right, low on the left, then high at the end. I mean, there's only one low value at the end. So it's bulky on the right, bulky in the high values, and thin on the low values. So this is definitely more skewed left. And again, you can draw a little histogram if you want. And then this last one, it's low for about 4 or 5 values, then it gets high, and then gets low again for about 4 values. So again, low on the left, bulky in the middle, low on the right. So much more symmetrical, this last one. So I'd say the only ones that were skewed were this one, skewed left, and this one skewed right. And let's see. There you go. All right, so again, you can make little drawings like this if you wish, make the histograms, or just kind of read the chart, read the frequencies. How high would these bars be? And if they start low, get high, and then get low again for a stretch, that's more symmetrical. If they start off high and then get low, that for a while, that's more skewed right. And if they start off low and then get high at the end, that's more skewed left. All right. Okay. And again, the explanations and all that. All right. Same kind of question. All right, so this time I'm not even going to bring up a picture, just to kind of describe it. So which of the following frequency tables show, again, a skewed data set? So you see how this is starting off low here, 2, 5, and then it gets bulky, and it stays bulky on the whole. I mean, there's one value at the end that's low, but it's low on the left, bulky for the rest of the right. So this is skewed left. All right. This one, again, it's kind of low here in the beginning, then it gets bulky, and it stays pretty bulky. Although there aren't too many bars here. It's 2, then 5, then 14, 13, 23, 26 are definitely the highest ones. And then 15. So like this block here from the value of 15 to 19, the heights that's where the bulk of the data is. And there's just a couple low bars on the left. There'd be a one low bar on the right. I'd say this is skewed left based on it starts off a couple low and then bulky, and then just one low bar on the right. I'm gonna pick that one and see what happens. This is low, then high, then low again. So I mean, the thing is though, there's only 2 bars. And maybe I should draw these. Low, then high, and low again, but there's only 2 low ones here, and then there's a few. And it is pretty stretched. There's like 4 low ones as opposed to 2 low ones. Alright, so what I'm going to do is I'm actually going to draw this one. Alright, I'll come back when I'm done drawing it. Okay, so I drew a histogram, again a very rough one for this, and this one definitely looks, when I'm actually looking at a drawing, more symmetrical to me than anything. Alright, so I would recommend actually drawing this stuff out. So back here, I'm not going to click on that one. So, and maybe this one I should draw out too, because I was kind of iffy about this one. And not really, because maybe I should draw it. Alright, so I'll be back with that drawing as well. And so again, for this one here that I've already marked off, it's very very rough histogram here. But if you look at this, it's like, and then not very short, not very long tail on the right side here, but there is definitely more of a tail on the left. So it's got more of a shape like this, you know, kind of like that. So see how it's bulky on the right, lower on the left, along, more stretched on the left. I'd say this was skewed. I'd say my initial reaction was good. This one was more symmetrical. And then this one here, see, it's low for one bar only, and then bulky on the left, stretched out on the right. I'd say this was skewed right. Okay, and I'm not going to make the drawing for that one. Should I draw this one? Maybe I should. I'll come back. Okay, so I actually went back. You know, I had this one marked off earlier. Maybe you should draw things, because looking at the drawing now, again, very rough, but I'm trying, you know, make your bars, make sure all the bars are about the same width and everything's evenly spaced. But looking at this histogram here, I'm seeing more of a symmetry. Low to high to low, bulkier in the center. So I'm going to unclick that one. I do apologize that I clicked it earlier. All right, I'm going to unclick that one. I feel now that it's more symmetrical based. So maybe you should either use your calculator or, you know, go on a piece of paper and draw a rough sketch of a histogram and get a good feel, all right, for whether or not the data set is skewed. All right, so looking at these, I got, you know, this one here looked like it was skewed left. This one here, when I drew it, looked like it was skewed right. Let me see here. Okay, great. All right, and again, my drawings and my histograms help me out there. All right, let me do that. Okay. I think I might have just one more here. All right, so this is the same thing. I'm just going to do, again, I would recommend you draw a little histogram for each, because apparently my guessing wasn't great, but if I had to guess, which ones were skewed, not going to worry about that. Yeah, draw your histograms. Let's see this last one here. Yeah, look, bulky on the left, stretched down on the right, low on the right. This is skewed right. This is low on the left, bulkier on the right. This would be skewed left, and it looks like those are the only two. Again, you can draw histograms just like the previous problem. And it looks like that's about all we're doing here. And like remember every section is going to be, you know, 1 to 6 objectives. This one only had one objective. All right, just determining if a data set was skewed or not. Now you saw it could take a little while. If you know, I would, you know, again, I'd recommend making the histograms, drawing a picture, or making a box and whisker plot. All right, you could also do that, make a box and whisker plot, and, you know, determine if it's skewed left, skewed right, or more symmetrical that way. Yeah, so that's all there is for this section, section 2.6, just, you know, identifying skewness. And another thing to remember is that if a data set is skewed left, oh, that's another thing I could have done. Found the mean and the median. All right, remember, if a data set is skewed left, the mean should be less than the median. If a data set is skewed right, the mean will be greater than the median. And if it's about symmetrical, right, like my last picture, right, like this picture here, right, if it's close to symmetrical, then the mean and the median will be pretty close. Right? This is not perfectly symmetrical. Only if they're perfectly symmetrical will the mean be equal to the median. So you know, if they weren't the same, you know, so I do the drawing as well too. I'd make a histogram or make a box and whisker plot. And if you want to compare the mean and median, you can, right, just for further evidence of skewness or symmetry. But that's it. That's the only objective here. Hopefully, again, you're not going to see the problems in the exact same order that I did, but the objective is the same. How I would go about working the problems is the same. The kind of problems you're going to see is all the same. All right, it's just you might see different numbers or a different order of the problems. So hopefully you can use this video as a guide to help you get through your assignment, you know, when you actually go through your section 2.6. All right, and of course, if you have any questions, let me know in Canvas, and, you know, thank you very much for watching.